Hi guys, Jason here. We're back for more Origin madness. This is an Origin 50, which has been modded to my Cali spec amp, actually, which is, look, it's a pre-tone stack master José, and the guy that sent me this amp, he bought it new from a retail store here in Melbourne, Australia, shipped it straight to me, and I have done the mod. Today's video, we're just going to go through a few tones. I'll show you kind of how the amp is set up, right, in terms of how I've configured it from the front panel, the pots and so on. And there'll be quite a lengthy description as we go into the second half of the video where I show you how to do the mod, right? And like I have done with all the Origin mods that I've posted on the channel, I will include a parts list document and as much help as I can give anyone who is brave enough to have a go at modding their Origin to this spec, right? This is a different kind of spec altogether. So the first one I did was more of a hot rodded JCM 800 2204 2203 style circuit, and that was posted on the channel maybe 15 or so months ago. The second one, which was posted quite recently, is the Plexi circuit mod for the Origin, and this one is the José mod, the traditional pre-tone stack master diode clipping mod. It's pretty gnarly, it's pretty aggressive, and it's another flavor, and it's pretty cool, right? In the intro clip, we're listening to me play through the amp straight in, right? There's no pedals, there's no boost, there's nothing like that. I'm going straight from this 2018, I think it is, yeah, 18 Gibson Explorer. It's completely stock, pickups are stock, straight into the front end of the Origin 50, and then into reactive load IRs and into logic on my door. So let's have a look at how the amp is set up. Okay, so on the front panel on an Origin 20 or a 50, right, we have a gain and a tilt pot. So in my Cali amp, which is set up kind of pretty similar to how a lot of the José style modern amps have been set up, there's two gain pots. So I have used the first gain pot is gain 1 and the tilt pot is gain 2. Okay, now there's a push-pull on gain 1 as well in the Origin, so that brings a bright cap in on gain 1. Okay, so pull bright, pushed in, there's no bright cap. And on the tilt pot, which is gain 2, I have put a bright cap on there, but it's permanent, right? It's not switchable. It's kind of how I like to have my Cali amp set up anyway. I always have the bright cap on gain 2, so in terms of the kind of tones that I want to get out of this amp, that's how I configured it. So let's have a look at how the amp responds to the two gain pots. That's this way kind of how you really dial the amp in. Obviously you've got bass, middle and treble and the normal EQ on here, but setting these two gains here, gain 1, gain 2, is really kind of how you can dial this thing in. So if I bring gain 1 back and then pull, we bring the bright cap in, you get that really kind of gnarly kind of top end going with this thing. Pushed in, you'll see that top end, it's still there but not as aggressive. Alright, I'll pull it back out again. So you can see, like, and with the gain back a bit on gain 1, that bright cap really starts to come into play. You can balance it out by bringing the gain up. Right, so remember this gain here is cascading into this gain here. Okay, so if I bring that up to say 9, you've still got that aggressive top end, but it's really going to start to fill out the mids here, and you get a bit more of a kind of, you know, tone that's not quite so scooped. So just bringing gain 1 back a bit, I'm going to show you what gain 2 does, right? So with this guy kind of cranked up, you'll see that it really starts to get a lot of bottom end in the amp. So you can really get a feel, change the feel of the amp and how much kind of bottom end is coming through with that gain 2. Bring it back. Hear the difference here, right? I'll bring it back up again. Really feel it. Pretty cool. If you bring it right back to halfway, say, remember the way that I've configured the mod, gain 2 has a bright cap as well. So as you bring the gain 2 back, you'll start to chop out bottom end through the preamp. You'll still retain that aggressive top end. So between gain 1 with the pull bright and gain 2, you can really kind of get quite a scoop sound, or a tone that where the mids and the bottom end is really pushing through as well. And just checking, yeah, the gain 1 is pulled, right? So the bright cap is in on gain 1 as well. Alright, fun for days. It's a pretty killer mod to the Origin 50, this one. This one's going to a customer down in Tasmania. It's the second Origin I've modded for him, actually. Have fun with this, guys. Do join our DIY builders group on Facebook, right? If you're thinking about doing this to your Origin and you've got a bunch of questions and you're not sure what to do, feel free to email me. But what I recommend is joining our Facebook group, and you will find a lot of help on there. There's over 1,000 people on the group now. Many of them have done the headfirst mods to their Origins and a bunch of other builds as well. We get heaps of help there. Join the group, post in there. I'll chip in and help as well. I will put a link in the description of the video for the parts list that's required to do this mod, so keep an eye out for that. If you haven't subscribed to the channel yet, please do. More than 60% of the people that watch my videos are not subscribed, so do me a favor. If you subscribe and click the bell, right, and you'll be notified of new content. I'll catch you later, guys. So here we are with the Origin 50, and look, having done a few of these now, I figured out you don't actually need to lift the main board out if you don't want to. Right? You save yourself a bit of hassle and remove the components that need to come out to do actually any of the mods, right? So this basic kind of structure here is the same regardless of whether you're doing the original headfirst JCM 800 style mod, the Plexi mod that I recently published, or what we're doing today, which is a full-on José diode clipping pre-tone stack master style setup. You can actually pull all these components out from the top, as I said. Now, for the components that you need to replace, you need to be a bit careful with how you do it, because you need to be able to reuse some of these pads, right? Other areas like here, where you're not actually going to replace anything, you just need to pull those components out. You can actually just go in there with the cutters and cut them out, right? And leave, you can leave the little stubs in there. Other areas, as I said, you just got to be a bit careful when you pull them out. So I've left one resistor in here, and I'll show you how I do it, right? Because you need to be really careful with how you pull these out. If you try and yank these out
before the solder is fully melted, you'll damage the PCB. So you do need to be careful with that. So one of the tricks that you can use to pull these components out on the top is get some leaded solder, right? Which is, you know, the only way to do it. Lead-free solder is awful to work with, and these boards are all done with lead-free, and you can, that's actually melted there okay, but you can just put a little bit of your leaded solder in there, and it can really help to free up the component. And then get your now you see, I hope that's come on the video, you can see there's movement there. As soon as you've got movement, you can just wiggle the resistor and it'll come out, right? And if that's clear, hopefully it is, I'll put the chopstick under it so you can see. You've got the full length of the lead there come out. And that pad is now nicely intact and could be reused, and actually might be. Once you've got one leg out, you can then repeat the procedure with the other side. Make sure you get your iron nice and hot. I've got mine up at 450 Celsius. Get in and get out. Now, don't try and yank it until it's clearly, you can see that's actually kind of just very free now. Wiggle, and there we go. The whole resistor has come out and I've got completely intact, nothing's left in there. If it does snap off and you're left with a stub, you can use your pliers to kind of, you know, grab the top of it, heat, and see if you can pull it out. Worst case scenario, you'll pull the board out and repair it that way, or get the thing out. The other thing you can do is get an offcut of a lead, maybe you know, like a that you've cut off a resistor or something like that. I do this trick sometimes. If something's stuck in the pad location, I'll heat the pad, and with the wire you can kind of plunge it into the pad and dislodge a little bit of resistor leg that might be stuck in the pad. Just a trick, does work. So I've started to kind of put some of the new components in, but I thought I'd just run the video again and talk about how to get these little caps out. All right, so I'm doing this without having to lift the main board out, so everything's coming off the top as I mentioned. But what about, you know, these caps, right? The resistors are pretty easy as I demonstrated. So what I do with these, here's a little, you know, grey one, right? So this thing here was like on there, for example. Just wiggle it gently back and forward that way, you know, so from side to side. Just very gently, back and forward, back and forward. You'll feel it start getting loose, and then it'll just come off. And what you're left with are the little leads in there, okay? As I mentioned with the resistors, if you're not reusing the component, you can just leave them in there, right? No worries at all. Otherwise, you can clean them out, clean out the holes, as I talked about before with the resistors. Same thing with this big electrolytic cap, which is here. It's siliconed in as well, or glued in. You'll just wiggle it back and forward. You'll feel it start to come loose, and then the leads will actually come away from the casing, and you'll be left with kind of quite long leads in here. Just, you know, apply the soldering iron to the pad, and you can lift the leads out. Okay, so our pre-tone stack diode clipping master José mod is done on this Origin 50, and I'm going to take you through it. I have modded this to basically my Cali spec amp, more or less. Right, it's a single channel version of the Cali. The Cali, if you know the amp, has 2 foot switchable masters, but effectively this is now set up the same, right? So the gain pot is gain 1, the tilt pot is gain 2. and these cascade into one another. So you can control the level of gain you're getting from the first triode, the first gain stage of the amp, into the second. The tone stack kind of remains the same. This is the master here. The master has been moved in the circuit to be before the tone stack, and the presence pot is pretty much stock. So with the board clean, as I just outlined in the previous section of the video, you can start kind of going about doing the mods to the board to implement the Cali circuit, which is, you know, effectively an implementation of pre-tone stack master diode clipping José mod. The mods on the main board are quite straightforward. The mods, you have to mod this front PCB, right? The PCB that is on the front of the amp, that is where the pots are mounted. You need to pull that out. I was able to complete the mod without having to remove the main PCB at all, which is really handy, but I did have to pull this out. It's pretty easy to pull out, right? You've got to remove all of the knobs in the stock origin. Just, you know, pull them off, right? They are not set screw knobs. They'll just pull off with a bit of force. Once they're off, you can unscrew the pots, pull these headers out, and it will lift off. So I'll go through these mods, right, and I'll attempt to do it in reference to the Cali schematic. Now, my Cali amp, I've actually open sourced that schematic. It's on my website, and you can go there and have a look at it. You know, download it. It's in PDF format, completely open sourced, right? So there's no trade secrets there, but I will show you how you can kind of take one of these amps and apply that setup, that scheme, onto this board. Obviously your guitar signal comes in here. This is where it comes in, right? This is your signal wire is the white, the black is a ground reference, which is connected directly to this cliff jack, which is mounted on the PCB board. It comes in here. This is V1A, or the first triode of your gain stage. These two you leave stock. This guy here, and I will get around to doing a parts document, okay? So everyone who follows these mods, oh, you know, can you do a parts list and so on? Yeah, I'll definitely do one for this. I'll just talk through it, and then I do a follow-up document, right, that tries to make this as clear as possible. But this is the cathode resistor for the first gain stage. You've got to move that to a 2.7K. All right, this is the cathode bypass cap for that cathode resistor. You've got to move this to 0.68 microfarad. This is the plate resistor for V1A, and it's 100K stock in the origin. So I've left it there, but I've pulled that leg out of that solder pad there, and you put a 220K in series, right? So this is now 330K plate resistor on the first gain stage. This plate resistor here is for V1B. You leave that alone, that's stock. This guy here is the first coupling cap off that first gain stage, and you need to remove the stock cap, and this is a 0.0022 microfarad coupling cap. These I'm using Mallory M150s here. Okay, and then off we go. Now you can actually see this trace on the top of the board. It comes from here, comes around, and actually moves to this header, and is moved on to the pot PCB via this wire here. That goes to the first gain pot. And in the Origin 50s, as I probably already mentioned, these are 1 meg pots. This guy here, and the tilt pot is 1 meg as well, which is fantastic for this mod. In the Origin 20, you could do this mod in the Origin 20, but these pots are 100K in the Origin 20, this guy and this guy. So you're going to need to pull them out and put 1 megs in if you're going to do this on an Origin 20. Okay, from here, your signal comes out of the wiper of this gain pot and comes back onto the main board. It actually travels down to this part of the board here, which is where we've had basically clean this out, right, in preparation for the mod. I'm trying to take some clear photos of this so you can see what's going on, but effectively, in my Cali schematic, you can see I've got two 68K resistors that lead into the input or the grid of the second gain stage, which is V1B here. This is the arrangement here. It's this 68K here, which is flying over the top into this side of C51, is it? And then this guy here, 68K, okay? And that leads into the grid on this side. This cap here is my switchable bright cap. Okay, so this push-pull pot on gain 1, what I've actually got this doing is that via this white wire here, this wire here is actually connected to the switch, this switch, and it's activating this relay, okay, in the stock amp. So, and this relay is switching, you know, these components over here in the stock amp. So I kind of figured out how to set it up so that I could reuse this relay to switch the bright cap on the gain pot, I should say, in and out. So when it's in, there's no bright cap, and when it's pulled out, the bright cap comes into play. You can really hear that, like when you play the amp. You know, that makes a huge difference, right? So as I said, I'll take some pictures of that so you can kind of follow along, but I've kind of done the hard work here to figure out how to reuse the relay for the bright cap. There are a number of you know, kind of wiring setups that I've had to do on the top of this board and underneath it. I will post some clear pictures of that and talk it through so you can kind of see what I'm doing there. But I'm just replicating what is in my Cali schematic and retrofitting it onto this, right? So we'll get to that. Okay, so once we come into the V1B, the second gain stage, now let's talk about this gain stage. It's a 100K plate resistor. You can leave that in there, that's stock. You need to replace this one. This is the cathode resistor. Again, it's 2K7. And this is the cathode bypass cap for that gain stage, which is 0.68 microfarad. Okay, so there are three things you need to worry about underneath the PCB for the pots, right? So you can see this photo, you can orientate yourself around this. I've got it flipped out of the chassis here and just flipped over. Now, first of all, this is our gain pot, and I've soldered in a cap here which runs from ground to the input of the pot, right? So just from the two outer lugs of the pot, you can kind of solder those straight in there. There's enough room in there to kind of put the cap in securely. You can do this to taste, right? Anywhere between 1,000 picofarad and 2,000. Actually, I'm using 1,500 in this amp, and what this is doing is taking some ice pick top end out of the signal early on in the amp. Okay, you can try it without it, but I think you'll find that it's just takes your head off. Okay, this one here is a 2,200 picofarad or 0.0022 microfarad. It's the bright cap. Okay, so on the second gain, which is our tilt pot normally, the second gain, I mentioned in the video that I've just got the bright cap hardwired in. This is how you do it, right? So from the input to the pot into the pot wiper. And just moving to another view here, this blue wire which you see that I talk about, which is heads off to the two 470K resistors, which is the input to V2B. This is coming off the wiper of this gain pot, right, the middle lug. So you can solder that wire onto that,
middle lug while you've got this thing flipped over, run it out, and it'll go to V2B. And just another view of the same changes. Here you can see the ground reference. I talk about this from the master volume. I'm just taking the ground off there. Here's our 15 volt Zener diodes here. Same thing again. You can see this is before I've applied the heat gun to this heat shrink. You can see the how these lift up as described, and you can see this was a 0.022 originally, and as I said in the video, I actually changed it to a 0.0022, and you can see how you link these right on top of the board here and break that track. Should be pretty clear. In the stock amp, this bypass, this cathode bypass cap gets switched off when the amp goes into boost mode, which is backwards. Right, it's kind of weird. So to make sure that this guy is always in, because I'm just using, remember I'm using my pull gain in the stock amp as just the bright cap switch for the gain pot. This Y here, this bridge here across R63, that'll make sure that that cathode bypass cap was always grounded, always has a ground reference, and is always in the circuit. So that's all cool. Okay, so from this second gain stage here, it actually is wired directly to this header here. Okay, and you can see I'm only using one side of this. So what you need to do with these, and I'll show you one here, these cables, which come in the stock amp, I actually cut them, right? So to kind of, you can see this one's left alone, right? And you can see this one's been cut, this one's been cut. There's a couple of mods here where, you know, wiring situations where you only want to use 2 of the 4 or 2 of the 6. And you can get these guys and get a box cutter, put it on a flat surface and get a box cutter. And you see where the groove is on there, just press down and it'll break apart and you'll get a nice clean cut through there, and you can reuse it in a smaller format, which is what I've done here. And I've cut the end off it. I've got a bit of heat shrink there that still needs a heat gun applied to it, so this amp's not completely finished. You have to forgive me, and you can see a little bit of heat shrink there. I might get the heat gun out and apply that before I continue on with the rest of the video. This is also a 0.0022 microfarad coupling cap, and this is the most kind of convenient way of getting it in. So this is heading into the input of what used to be the tilt pot, is now going to be used as gain 2. Okay, now in my Cali amp I have this as a 0.022, and that's what I had in here originally when I first did the mod, but I found the amp had too much bass, just kind of farting out a bit on the bottom end. So 0.0022 on the first coupling cap and 0.0022, it's the same on the second coupling cap, is keeping the bass a bit leaner as we move through the preamp. Just noting on top of the board here, as I said, I will show some pictures of the bottom of this. You can see how I've set that up. You can see I've kind of bridged these guys across just with link wires. You got to disconnect this track. So I use a drill, actually. Get a drill bit. This track here, which is it connects the trim pot, the tilt pot, I should say, not trim, the tilt pot, to the gain pot in the stock amp. You need to break that connection. Okay, so just make sure you cut that through. You can use a box cutter again, and you can kind of cut that track there, but just a drill bit is a really easy way to do it. Now, out of the second gain pot from the wiper is this blue wire here. Okay, now in my headfirst origin mod, we reuse V2 as part of the core circuit. This is why the effects loop gets disabled. Well, people would ask me, right, oh, if I do the mod do I lose my FX loop? Yes, you do. But we have a board, I've got one here. This amp will have an FX loop put into it. I haven't done it yet, right? I'll do that as the last thing. But you put one of these in. Here's one that's made up. It's actually ready to go for an Origin. It's came out of my own Origin amp actually, because I removed this when I did the Plexi mod on my Origin 20. So I'll probably reuse it for this amp. It's a perfectly good loop. But what we do is we put this in like so and connect it into the send and return jacks on here. I have a video already posted that shows you how to do that. The procedure here for the Origin 50 will be the same. Okay, so you do lose the FX loop with this mod, so you do need to grab one of my boards, or a Metro loop board will work as well if you want to restore the FX loop. So from the second gain, we need to get into this side of V2. All right, so in the Origin mod, normally in a Marshall, you'd go, from this triode to this triode to this triode, and this would be your cathode follower. Well, because of the way this is set up, because it's in the stock amp, it's set up to drive the FX loop, these are actually backwards. So this is why you've got to come into this side of V2 first, and then we go into this side of V2. So this blue wire here is coming in to the top side of whatever that is, C50. And then we've got our arrangement here. This is the same as the standard headfirst JCM 800 mod, 470k resistors with a 470 picofarad pica cap sitting on top there. Okay, and that sets us up to connect into the grid, or the input of this side of V2. Okay, 100k plate resistor, that's stock, you leave that alone. And this blue wire here, which you can run on top of the board, in the first Origin mod I posted, I had this underneath the board, but with all this removed, you can just run a wire from this side of C30 over to here, to the top side of this guy. Okay, and from there we set up the cathode for the cathode follower and cathode resistor. So let me tilt this and let's see if it's coming through on the clip, hopefully. Underneath this capacitor, there's a 100k resistor to ground. Okay, you can link this guy here, and that'll give you a ground reference for this resistor here. 100k to ground, that's standard cathode follower setup in a Marshall. Then I've got a 10k resistor coming off this top end, and it's connected to this cap. This is a DC blocking cap, like a coupling capacitor, and this sets us up to be able to connect over into our master volume pot. And you can see I've got a little bit of hot glue here, that's just, because that's just sitting on top, obviously. Nice and secure now, and I've got some shielded coax here, which takes us over to the input of the side, the input of the volume pot. It's a 1 meg linear pot, not a audio, not a log pot. I've used linear. You find when you do pre-tone stack master diode clipping that the taper on the volume pot will be a bit strange when you've got diodes in. It's when the diodes are switched out, it's normal, but when the diodes go in it, you'll find that you have to really crank it all the way up before you kind of get any volume of note. A linear pot solves that to a large degree. This amp, this customer, we're not doing switchable diodes. The diodes are in permanently. So I put a linear pot in there, so the taper on the volume will be a bit more kind of as you'd expect. Okay, let's have a look at this volume pot, and you can see here I've got my two Zener diodes back to back, or front to front, right, in opposing directions, running from the input of the volume to ground. And you can see this black wire here is what's giving me ground reference to the pot, and that ground is actually connected, and under the pot it's connected to
the ground pad for the volume pot that was there, because I pulled the volume pot out of the stock PCB and replaced it with my linear pot here. Okay, so using the ground pad that was there for the PCB mounted pot, I've got a ground reference for my volume pot. Here are my two diodes. Now you can play with these values. Okay, if you want just kind of mild clipping, try 24 volt Zenas. That's probably as high as you'd go. You can go all the way down to 5.1 volt, and at 5.1 volts it's super compressed and gonna sound really kind of gainy and distorted. I've used 15. These are 15 volt Zenas in here, which, you know, maybe a bit of a personal preference there, but I find anything lower than that, it's just, for me, a bit too much. And I know this is a customer's amp, it's not for me, but, you know, amps that leave here are amps that I would have myself. That's my theory. From the wiper of the volume, you need to connect this to the input of the tone stack. And the way to do that, on the origin front PCB are the components for your tone stack, right? So this is your slope resistor here, 33K. This is the 470K picofarad treble cap, and here's your mid and bass 0.022 microfarad caps. So if you lift the slope resistor on this side, lift the treble cap on the other, join them together, you'll be able to connect the output of your master volume to the input of your tone stack, and kind of gets around, you know, how this is hardwired with the PCB. And from there, you can use one of these cut up harness wires, want a better term. You can see I've cut one end of it off, and at the moment I've just connected that to the third pin, 1, 2, 3, third pin of this header. That gets you into the input of the phase inverter. Okay, that gets you into the input of the phase inverter. This is temporary. If you're not putting my effects loop in, one of these, right, then you can kind of make that permanent, right? Like done, you're done, right? You're done. But our effects loop is going to sit in between the treble wiper and the input to the phase inverter. So when I put this in, this guy's gonna come across to here into the input, and then the output is gonna go to this pin here for the phase inverter. Okay. Now, with respect to the phase inverter, there are a couple of changes you need to make. Well, you should make. You don't need to, but you should make to make this back to kind of stock Marshall. And it's these two resistors on the outside in the stock origin 50 and 20 actually. These are 470K resistors on the outside. I pulled them out and put 1 meg in. That's stock Marshall. 1 meg is the stock Marshall setup. And I've also put my fixed depth, well, not mine, but I've put a fixed depth circuit in here. So this is 100K negative feedback resistor. R90, have I got that right? Anyway, you lift, this is just like in the original headfirst mod, lift this side of it, lift it up. This is a 220K resistor with a 0.0047 microfarad ceramic cap, and in parallel connected to the 100K. That'll give you a nice depth circuit. Now, given that we've leaned the bass out in the preamp, right, this will give you a nice, you know, bottom end thump back into the power amp. And while we're talking about, now just with respect to the B plus line, the DC supply line for this amp, the Origin 50, the preamp voltages are really high. They're, way higher than a kind of standard, 1987 or 2204 Marshall. So I've replaced one of the drop-in resistors here. I can't remember what the stock value is. I think it's 4K7. But this is, this guy here is, I pulled that out and I've replaced it with a 2-watt 10K resistor. Okay. This will get your voltages of the preamp kind of more, closer to what you would see in a modded JMP, which is, the original José mods, of course. We're all mostly on kind of JMP era Marshalls. The phase inverter voltages are pretty high, but I think the amp gets away with that as long as you've got V1, V2, kind of in the ballpark, which changing this to 10K will get you there. Then the amp will be fine. The amp will sound great. Just one final thing. This is you can see on these headers here. Again, I'm using just a two-way connection, which I've used from cutting up one of the existing harness wires. This keeps your presence pot in place, right? So you don't want the rest of this because we've completely reconfigured how the master volume works. And in the stock amp, this header here is for the master volume and the presence pot. So yeah, if you have, as long as you keep that connected just on those last two, your presence will be all set up and all good. Also note, just the plate resistor here for V2Bs, R55, right? That's 220K in the stock Origin, so you do need to replace that with a 100K. The 220K that you pull out of there, use that on this guy. This is the 100 with the 220, so you can lift that one out, reuse it here, get yourself a 1-watt carbon film 100K to put in there. All right, so if you progress on to install the loop, you're going to end up something like this. All right, so you can have a look at my Origin 20 effects loop install video to get the general idea of how to do this. With this Origin 50 setup, a couple of things to point out. The Origin 50 does run much higher voltages than the 20, so you need to set up your drop-in resistors here. I've got a 47K as my main drop-in resistor on for the power supply on the loop board, but I've also running a 22K, and I'm tapping it off this side of this 4K7 dropper here. So this is on the other side of the phase inverter actually. So this is giving me just over 300, about 310 or so on the board for this, which is what we want, volt DC. And in terms of getting the loop in, you need to the loop needs to sit in between. This is the treble wiper here, output from the tone stack. All right, and this header here, this is your input to the phase inverter. This white one here. So 1, 2, 3, count them. Right. So we're coming out of the tone stack to the input of the loop board, and the out is this shielded coax here, which I've joined onto another one of these harness wires to allow this just to be clipped in quite easily. You notice before I put the loop in, I was just running this across and tapping it straight into here, just as part of my testing. I always want to verify that the amp's working fine before I progress on and worry about putting an effects loop in. Okay, so just finally, I'm going to measure some voltages in the amp, and you can use these as a reference for when, if you do the mod yourself or you just want to check your voltages in the Origin 50. First up, power scaling. I've left the power scaling in. One very common question that I get asked from people that have done the JCM 800 style mod, and this will be no different, is, oh, my power scaling doesn't work anymore. Well, it does. It's just that when you do that JCM 800 mod or this mod, you're putting a master volume into the amp that is meaning that you're not driving the power section anywhere near as hard. The Origin circuit is kind of relies on some saturation and compression in the power section.
of the amp, and that's where you kind of the power scaling makes the most difference. But if you turned your volume, if you've done one of these mods and you turn your volume all the way up, your master volume up really loud, you'll find the power scaling works, because all of a sudden you're starting to, you know, utilize and saturate the power section, and the power scaling will come into play. So it does work, but you'll find with these circuits, you're getting all of your kind of drive tone and overdrive out of the preamp. So you don't need to drive the power amp anywhere near as hard unless you're totally cranking it, in which case you can just leave the power scaling on high. At least that way I know that the voltages through the amp are pretty good. All right, so let's just move this to the side a bit. So if you want to check our plate voltage on one of these guys, the easiest way to do that is on, see these blue and brown wires here? These are straight off the output transformer and connect to pin 3 of your power tube. And I've got 455 DC. Okay, 240 volts at the wall here in Australia. I've got my variac dialed in, it's bang on 240. Let's check the voltages down here. At the top of this 82k resistor, that is your node supply to the phase inverter. 410 is pretty high. All right, most Marshall amps, you know, the JMPs and so on, you know, somewhere between 330 and 370 normally. So it's pretty high, not the end of the world. This side of the 4K7 resistor, 446, right? So this is the supply node, the B plus line for the preamp, and it's not connected to the phase inverter. You can see my previous videos on the origins to understand why that is. It's to do with the power scaling. So this side where I've got the loop coming off of that 4K7 resistor, I've got 415. So you can see it's pretty high, which is why I need the 22K. So on the entry to the loop board, I've got 380, and then on the other side, 316, 315. And if I tap this positive terminal of the electrolytic cap, 315. Okay, that's okay. It's kind of at the upper end of what you'd want to supply your loop board with, but at that level, it's okay. Over here, this is replace this, right? A 10K drop-in resistor. So on this side of it, we've got our 415, 365, and that comes down to this other 10K, 365, and the other side, 349. So if I go all the way to pin 1 of V1A, all right, I've got 160. That's pretty good, right? You probably wouldn't want it much higher than that, I find. It starts to get a bit, I don't know, just not as pleasant. Strident is the word, I think. So I kind of aim, in these kind of amps, 140 to 160 P on V1A. And just in terms of grounding, this board, you do need to ground the loop board. Okay, and this is my black wire here, and I've run it as an empty pad here, R57. This is 1, 2, third one along on this side. You can check it with your meter, right? There's a ground reference right there. So I'm just tapping the ground off that. The send and return jacks, you can have a look at the Origin 20 loop installation video to see how we do that. This allows you to reuse the send and return jacks on the rear of the chassis. No drilling holes or anything like that.